Hello everyone, this is Mr. Appel, and I'm going to show you how to graph this properly. This is piecewise, so we've got to focus on one piece at a time. Haha, hence the name. So the first part is the 1/2 x plus 3. That's way too thick, sorry. And so the idea is it's only defined to be 1/2 x plus 3 for x values less than or equal to 2. So start at 2 and then work your way to the left of that, numbers that are less than 2. And you can, whoops, I don't know what that was. You don't necessarily need a whole lot of points to plug in if your understanding of functions is good. So for example, here, if you recognize that this is a linear function, really you only need 2 critical points. But if it helps you to plot more, you can. Also, I like to use this little trick of sort of thinking about x less than or equal to 2 on a number line. Because it's or equal, it's a closed circle because it includes that point, and it's going to continue in that direction. So we're going to come back to that idea in a minute. So when x is 2, half of 2 is 1, 1 plus 3 is 4. I'm going to ignore the fractions. I don't want to deal with fractions, so I'm going to skip this one and go to 0, because half of 0 is 0, plus 3 is 3. I'm going to use even numbers here, so half of -2 is -1, plus 3 is 2. It's a line, so that's plenty, so I'm going to plot those points. And again, because it's or equal, solid closed dot there at 2, 4. Let's plot 0, 3, and -2, 2. And it continues for all x values less than or equal to 2. So that's where this number line piece idea comes from. When you graph that on a number line, you'd start it there at 2 and then go to the left forever or down forever. So we're going to the left forever. And so I'm going to start there and continue on. I'm going to use my straight edge tool to make it nice and pretty. And there's my line. I do draw the arrow because it's continuing on forever in that direction. Okay, but to the right of 2, it's a different function, right? So let's change colors. It's absolute value of x minus 4 for x values that are greater than 2. So we're going to do that. So I'm actually going to include, now this is a little counterintuitive. I want to include 2, even though 2 is not included in this function. And I'm going to include numbers greater than 2, and I'm going to explain why in just a second. So if we plug in 2, 2 minus 4 is -2, but the absolute value of -2 is 2. 3 minus 4 is -1. Absolute value of -1 is 1, and then 0, and then 1, and then 2. But remember, if we're going with that number line idea again, if this helps you, right, it's x is greater than 2, so that would be an open circle on 2, and then an arrow going that way to show that it continues on for all numbers greater than 2. So let's plot those points, but this key point 2, 2 is critical because at that point it isn't defined yet, so that's an open circle. But everything to the right of it is. So 3, 1, and 4, 0, and 5, 1, and 6, 2. And so that is what our graph is going to look like. The reason why it was so important to plot the point when x was 2, even though the function isn't defined there, is so that tells us where that open circle is. And what's critical here is that we don't miss out on all the numbers between 2 and 3. The mistake that many people make, and you may have made this mistake, is that since it's not defined at 2, you're like, oh, okay, cool, I'll start at 3. The problem is there's a whole lot of numbers between 2 and 3. There's infinitely many of them. 2.0001, 2.1, 2.2, 2.27, 2.8, right? There's a lot of x values between 2 and 3. And so if you start it at 3 and then graph the rest, you're missing out on all those numbers between 2 and 3. That's why that open circle idea is so important. Hope that helps. That's all for now. Thanks.